All right, centroid calculation practice. What we're going to do is we're going to take some simple shapes and we're going to try to find the centroid location, or where the center of mass would be located, of this like two-dimensional object. And we're going to do a couple of semicircle examples and we're going to do a triangle example. And we have to remember the formulas, the quick references for the centroid locations for a semicircle. And let's go ahead and go over those first. Let's make a reference point. I always like to go towards the bottom left. So I'm going to just make a tick mark right here and I'm going to write O for my reference position. And I'm going to be looking at this, let's see, semicircle, and I'm going to say, let's say that this object has a diameter of 10, so 10 units going all the way across. That means each square would be 2, 2, 4, 6, 8, 10. So in the middle, we're going to say that this is 5 from the reference point. So that means that this semicircle would have a radius of 5. Now, you remember that there are two different locations for a semicircle. The one location, and since this semicircle is on its side, the y direction is going to be just the halfway point between the two. So the y bar, since we can cut a line in half, the y bar is just going to equal 5 units. The X bar, we're not so easily fooled though. So the X bar, since it's going left to right, there's no way that I can cut it in half and have it actually make sense. So we're going to have to use the formula for the long side of the circle. And the formula for the long side of that, or I guess the circle-y side might be the better way to put it, is 4 times the radius divided by 3 pi. Well, in this case, that's 4 times 5 divided by 3 times pi. And I'm kind of looking for things to cancel out, but in this case, 4, 5, 3, and pi, these numbers really don't work out really nicely with each other. So we're going to have to calculate and see if we can get these numbers to decimalize real good. I know math teachers really like to keep pi's in the problem, but A, pi's in the denominator, so that's not okay. And B, we're engineers, so we don't care. So we're going to divide by 3, and then we're also going to divide by pi. Let's see if I can actually get it to work. All right, so hopefully if I can calculate this right, it looks like the x bar location is about 2.12 units across. So if I were to try to write this centroid location, I'm going to write it as an ordered pair. I'm going to write it as 2.12 for the x bar. This would be x bar. And my y bar is going to be 5. And what this will do is it will give me my x and y location for this centroid. So 2.12 is going to be located about right here, a little bit below the halfway point. So let's see here, 2, 4, this is supposed to be, oh, hang on, 2, 4, semicircle. So this should be 5. So that means, sorry, 2.12 is going to be a little bit lower down here. So that's going to be our centroid location. Let's go for a different setup. Let's go for a semicircle that goes this direction. So now look at it's the same concept. It's still a semicircle, but it's going down. And let's just say that the diameter is 5 this time, which means my halfway location going across, because this is 1, 2, 3, 4, 5. Let's just say that my radius value, oh, let's see, I think I actually used 5 in a problem. So let's make our life a little bit more interesting. Let's say that the diameter is 20, so that means that the distance from the radius value is going to be 10. So 10 units from the left of the center of the circle or the semicircle, and 10 units to the right of the value of the semicircle. So one of these we can cut in half. So I'm looking at this and I'm saying, all right, well, this one I can cut in half, and that's an x position. We need to make a reference point, and I like to use the bottom left, but unfortunately for us, the bottom left is not really an option right now, since there's no like vertex down there. You don't really want to put your origin down, or your reference point down at the bottom left. You want to actually go up to the top left. So what I'm going to do is I'm going to go up to the top left, and I'm going to make a crosshair like this, and I'm going to put an O for the origin. And that's the reference point that we're going to be making for our location. So I'm going to kind of look at that and say, all right, well, my x bar is going to be a very easy, just cut the number in half. So my x bar is really just going to be 20 divided by 10, or sorry, 20 divided by 2 cut in half, and that makes it 10 units. All right, and then the y bar location is going to be, we're going to have to use that formula again. So we've got a semicircle, and that semicircle is, I can look at it and say that, you know, if this is the halfway point, then it's going to be a little bit below. So it's going to be somewhere around right here-ish. But to get the exact number, we're going to have to take that formula and we're going to have to use it for the centroid location of a semicircle. So it's going to be 4 times the radius divided by 3 pi. And I don't think our life is going to be any easier this time, because it's going to be 4 times 10 divided by 3 times pi. And nothing cancels out, unfortunately, which means we've got to throw everything in the calculator. It's 40 thirds pi, or 40 thirds divided by pi. I don't know, it's a really weird way to say it. I'm just going to multiply it. 4 times 10 divided by 3, and then I'm going to divide that by pi, and I get 4.24, and that seems like a reasonable answer. I'm going to do 4.24 units. So if I were to write my x bar and y bar, you're going to write it as an ordered pair. So it's going to be 10 for the x direction. I'll go ahead and just write units out to the side, and 4.24 units as well. These could be like inches, feet, meters, millimeters, it doesn't matter. They go by the same concept anyway. All right, and for the last one, let's try a right triangle. I'm going to scroll down this so we can actually see the right triangle here. There it is. Once again, I like to use the bottom left for a reference point to try to find the center of mass of this object, but it doesn't really, I don't have a bottom left, it doesn't exist. So we could really, honestly, pick any one of these vertexes that we wanted to. I'm going to go ahead and pick the top left one specifically because, ooh, you know what? I've already done messed up. Yeah, okay. Because I was getting ready to say that I wanted to pick the top left for a specific reason. Let me go back up to the semicircle. When you go down 4.24 units, you're going down 4.24 units. We're not going up 2.24 units. So from our reference point, since we're actually going down, we're going to use this as a negative number. So it's not going to be 10 4.24, you're going to use it like it's a coordinate system in algebra class. It's 10 and then it's down to 4.24. That's really important because when you start making more complicated shapes, if you've got some above the reference point and some below the reference point, you're going to have to take into account which direction. You know, if they're above it, that's going to be a positive number. If they're below it, that's going to be a negative number. So the 10 is positive, and that's to the right of the reference point, and that makes sense to me. The down one I just was going a little too quickly on, so I apologize for that. That's negative 4.24. I'm going to show you the same example on this right triangle as well too. We need the formula for a right triangle, and the base is going to be over here. So every time we calculate our base, it's going to be 1/3 from the heaviest end. So let's see here. Let's say that this has a side. Let's see, this 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, let's go ahead and do that. So we got a side of 6 and we got a side of 5. We'll just count the squares in this case. So if I'm trying to find the center of mass or the centroid of this location, it's 1/3 of the base from the heavy side. So this is the heavy side. So 1/3 is going to be about right here. And from the heavy side right on this side, 1/3 is going to be about right there. We can go ahead and we can calculate those out. The one on the top is easy, and the one on the bottom, we're going to just have to make a fraction out of it. So our x bar is going to be, and here's where things get a little bit interesting. So if this is 2 squares over this way, from the origin, it's really 4 squares. The center of mass is really 4 squares over here. So we can do 1/3 of 6, but that's not actually our distance to the origin point. So our x bar is actually going to be 4 units, because we're counting from the origin point. So this position over here is the most important position that we have. Okay, and let's see, for the y bar, we're going to do the same thing. So for the y bar, we're going to do the actual center of mass location is going to be this location right here is going to be 5 divided by 3. And since we're counting down to that position, the 5 divided by 3 from the heavy part is going to be the same from our reference point. So in this case, our y bar really is 5 divided by 3, or 5/3, we can take that into a decimal and make it 1.67, rounding a little bit. So we're going to be 1.67 units. And now look at what direction it's going. So the direction is downward, so we're going to be going negative 1.67 units. So if we were to try to make this an ordered pair, our ordered pair would be 4, comma, negative 1.67, and that would be our centroid location. So if we were to actually write this on the grid, that would be 1, 2, 3, 4, and then 1.67. Hey, I was actually pretty close with that. It's a little bit past that halfway point. So our centroid location would be about right there. And that's a couple of examples of how to use the centroid simple shapes to calculate the centroid of like a right triangle or a semicircle. The rectangles are not really too bad. You're just cutting it in half every time. Just be careful about where you're going in relation to the origin. Y'all have a great day, and I will talk at you guys later.